Awesome. Let's give it 2 more minutes, folks, and then we can start. All right. While other people join, I think we can get started. Super. Awesome. I'll let people in as they come in. First of all, welcome to everyone. Thanks for joining AppliedAI again. So really glad that we are going on second year, at least from a calendar year point of view. So I see a lot of new faces here. So I'll give you a sense of like what we do in this community, and then I will start the session. It will not take much time. So AppliedAI is mostly a an open community for folks to learn and work with AI. So we're mostly focused on non-engineers and non-students. So we started this about in Feb last year, and in fact, one of the first requests for starting the session came from Gautam, who is our presenter here today. So really glad to see how the community is actually grown. So essentially, we do 2 things in these communities. Every Saturday morning, we have an expert session where an expert comes in and talks about a specific topic on AI. And so like today we are having evals. Next week we have something on cloud code. So we have something every single week. We try to make it as, every single week. Sometimes it gets missed. Right? The second thing we do is we run some self-learning study groups. So where we get a group of people in, and over a 3 to 4 weeks period, so people learn a particular topic. We are predominantly things like learning to write code or learning to use NATM, etc. So we have 2 more such cohorts coming up, which is focused on fine-tuning LLM models. Second is building voice applications using LLMs. So we're doing some of these cohorts in the upcoming weeks. The third thing is that we have a WhatsApp group. So we have about 500 folks over there. So which is focused towards discussing and learning on like everyday topics. So this is what we do. Everything we do here is open and free, and even these sessions are being recorded and they'll be posted on YouTube. You can see our past sessions over YouTube, and a lot of folks have actually found it quite useful, right? So if you do like it, try to join the group. I think it will help the community also. Awesome. So without further ado, we'll get into today's session. So Evals has been like one of the most topics every few months. We have our first session on Evals was done by Gautam, and it is one of the most viewed, I think the most viewed video in our channel. And so we even the last December, we had a specific session on evals with respect to RAG, which was taken by Pavan Manta, and which was an amazing session. But we still thought that we need an eval which is mostly focused on like not just RAG, but like an entire AI infrastructure point of view. So that's when I reached out to Gautam, and Gautam was kind enough, to spend his weekend time with us to take us through this. So a little bit about Gautam. So Gautam is a friend of mine. So we both studied together at ISB. That's how I know him. And so over the years, we've kind of like kept in touch. And he worked at Microsoft, mostly working on ML architecture before the pre-AA days. And when AA actually started, he worked very deeply in Gen AI, closely working with some of the closest to Microsoft partners, like the big names you can actually think of. And he's also specifically worked on evals. He's done a lot of internal sessions at Microsoft on evals. And recently he's joined Intuit, and he does similar stuff over there. And I can't think of anybody better to see from the lens of a product manager or a builder to think about how to construct evals in a good way, right? So before I hand it over to Gautam, so few things about session. Just make sure you drop your questions in the comments, because we have a fairly large audience. We don't want to keep interrupting the flow. So if there are times where Gautam can take the questions, we can interrupt him and give him all the questions that he can answer. Or we'll also have some time towards the end where he can take up all these questions. Yeah, so that's about it. And Gautam, over to you, man. Thank you so much for joining and taking this.
Thanks, Bala. Thanks for the. Am I audible?
Yes.
Yeah. Thanks, Bala. Thanks for the kind introduction. You always, give such great introductions and put me in a lot of pressure. So, hello everyone. Nice meeting you all on a Saturday morning. And first of all, kudos to Bala for running this for so long. I know I was one of the when Bala and TPK had started sharing some of this content on LinkedIn. I had requested them to, hey, why don't we make this more formal? Why don't you actually show what you're doing to us rather than just showing the final output, which anyway everyone was showing. And then when they started it, I thought maybe 2 months, 3 months, let's see where it goes. And now it's been a year, right, Bala? If I'm not wrong.
We started Feb, end of
Feb.
Yeah.
It's a year, and sessions having like Saturday mornings, 50, 60 people joining, and then there are so many other cohorts that they're running. I mean, I also noticed that they're running some walking cohorts. People who are interested in walking as part of this, and yeah, I'm super happy to where Bala TPK have brought this, and I couldn't participate in between due to some personal issues, but I'm looking forward to participating more going forward. So with that, I'll get started. Let me know if you can all see my screen.
We can, yeah.
Perfect. Okay. So, I've kind of broken this session. So, quick context, right? I've focused on agent evals. I've not focused on general evals. I've focused on agent evals. Of course, evals in general will also be part of this. And another thing is, I've kind of broken this down into 2 sessions because doing all of this in one session was not being possible because the topic was fairly deep, and the topic has also become quite more, many more things have come up since the last time I took this session. So today's session, I'll focus primarily on the observability part. If we get time, we'll go into agent evals, talk some basics about evals. In the next session that I do, I'll do some hands-on. We'll try to do some hands-on on how to do evals for different types of application, not just RAG. RAG, I think something we've done before. We'll try to do evals for other types of agent patterns as well. Say, like trajectories and all, right? So that's what we'll try to do. So with that, get started. So first of all, why is agents harder to evaluate than regular software? Of course, let's just take in the context of a trip planning agent, right? Let's say there's a trip planning agent where you can say that, hey, I want to plan this trip, or I want to fly somewhere, I want to, can you book me tickets? There's a bunch of steps it takes. The agent, of course, figures out what tool to call, what to do, and then based on that, what tools to call. It makes calls to those tools, then it uses the context that it has already, and it uses the context that the user has given. Then it constructs a response, sometimes makes some decisions, and finally shares the response back to us, right? So there are multiple steps these agents go through, and there can be failures in each of these steps. That's the crucial part here, right? So all of this for us kind of becomes a black box, and we think that, hey, we ask this question and there are multiple steps that happen inside. So let's say, the initial understanding of the agent, the intent understanding of the agent could be wrong, or let's say the way it constructed the request to a particular tool could have been wrong. Maybe it constructed the params wrong, right? Or the response from the APIs or a tool that the agent called, the response could have been wrong, or the way the response was interpreted using some of the context that the agent had could be wrong, right? And finally, the way the response is relayed back to the user, maybe there's a certain format or a certain length or a certain style in which we expect the response to come through, that could be wrong. So there can be failures at multiple stages, right? That's what is the complexity that gets added when you're trying to evaluate agents. There's multi-steps, failure points are hidden, and just evaluating the final output like we used to do in traditional software does not work for agents. Of course, trajectory, there are trajectory blinds. But now what's a trajectory? Trajectory is the steps that the agent takes while coming up with a final solution, right? So let's say you ask a question, it does a bunch of steps internally, does some thinking, does some reasoning, does some calling tools, evaluating the final response, does a bunch of these things, and then gives you a final answer. And there could be incorrect trajectories that it follows, right? And then there's also subjectivity, right? What might be great for one person might not be a great answer for another person, right? There's not a clear defined ground truth, unlike categorical solutions, right? So, and then finally, non-deterministic behavior. Agents, of course, use generative AI models underneath, and generative AI models are non-deterministic. What do I mean by non-deterministic? You ask the same question 2 times, you don't get the same answer. Right, so that's non-deterministic, right? And sometimes it also learns. There's some emergent behaviors also. It learns something, it stores certain things in the memory, and then you get some emergent behaviors as well, which is different from the previous response that you got for the same question. So that's of course the challenges, right? Just to give a quick comparison between traditional software and AI agents, I think especially for the product managers out there and testers, traditional softwares, rule-based, very fixed logic that it follows, deterministic outcomes. We just spoke about what is non-deterministic. Deterministic is you give the same input every single time, you get the same output in traditional software. And then there are much more simpler pass-fail tests. Because the output is deterministic, you can set up tests that can pass and fail, right? You can set up tests that, hey, if output is X, then it's pass. If output is not X, then it's fail, right? It's as simple as that. Then the evaluation metrics are fairly known because most of us are aware of, hey, accuracy is one very widely accepted evaluation metric for a traditional software. Or say coverage is something that we say, hey, how many times does it really give an answer? Maybe latency, things like cost. There are certain standard evaluation metrics or standard operational metrics that we have for traditional software, which we can use. And finally, there are so many tools out there for debugging for traditional software, so it's easy to track what decisions, how they are progressing, and it's easier to debug, right? Of course, if I put a negative to all of this, that's how AI agents are going to work. AI agents are autonomous, complex. They take decisions on the fly, non-deterministic outcomes. And then there is evolving and ambiguous metrics. We'll get into more details on why it's evolving and ambiguous metrics. Unlike your regular traditional software where the metrics are clearly defined, here, depending on the use cases, depending on the agents that you're trying to build, you might have to change your metrics, right? It's not standard metrics everywhere, although there are standard patterns like RAG, where there are certain standard metrics. Depending on your use case, you'll have to figure out what's the right metrics that makes sense for your specific use case in your specific domain. So it might not be one size fits all for every single user, every single agent. And finally, harder to debug. If you've tried debugging an agent, we'll try to see how the debugging happens in an agent, right? It's much more harder in terms of following the trajectory, why the handoff between different tools, the handoff between different agents, following all of them, understanding where a failure happened, especially when there is no deterministic output, is much more hard. So essentially, the final difference I'd like to say is in traditional software, the question is, as long as you get the logic right, you're and you know the metrics, and it's easier to debug, and it's easier to create eval. So it's more about, have you built the right product? But here within an AI agent, it's not about building the right product, it's building the product correctly as well, right? So you might have a great idea, you might have great logic, but then the product might still not turn out exactly as how you wished. What are the different types of failures that have started to come with AI agents, right? So these are some of the top failures that we start noticing, right? So AI agents don't fail like traditional software. It's not like there's a system crash. There is no like sudden failure, right? Like it's not like everything is going 100%. You're measuring your availability, you're measuring your latency, everything is going great, and suddenly it goes to zero. And some bug cropped up, and you got to go and fix that bug. It doesn't happen that way. A lot of times there are subtle drifts, right? Now, what do I mean by drifts? Drifts are basically when there is a slow degradation of quality or slow change in behavior, right? Let me give you an example. Let's say you have a travel agent, and you see that it's performing great, especially you've kind of launched it for, say, a particular geography. Let's say you've launched it for India, and it's performing great. And typically people ask questions about traveling within India, and you see that it's performing great, right? Over a period, you see that slowly, let's say by performing great, let's say there's a metric called accuracy, the accuracy at 95%. Like let's take an example, right? Slowly you see that the 95% becomes 94%, 93%, 92%, 91%, and suddenly goes below 90%. Now, there could be many reasons for it, but what's important to understand is there can be a lot of drifts that can happen, right? So let's say one interesting reason could be, what if the users who are traditionally asking say questions about India have now started asking questions about worldwide travel, right? Maybe that's something the agent is not great at responding. Or maybe what if the user's questions have become a lot more specific? Let's say traditionally they were asking questions with say about 50 tokens, and now they're asking much more specific questions which are about 100 tokens. Maybe that distribution drift is causing a drift in the performance of the AI agent, right? So there could be so many reasons. Even input drift can be a reason for AI agent to show these degradation of quality, right? So that's one. And apart from that, there can be algorithmic biases because of the data with which the AI agent has been trained. There could of course be hallucinations based on AI agents. Of course, the underlying generative AI models are biased to respond even if they don't know. Then there is emergent unintended behaviors. Agents start developing more novel strategies when they're trying to achieve its goal, even though it's not expected out of the agent, right? So overall, the kind of errors that you encounter in AI agents are also totally different from what you encounter from traditional software. So before we take an example of how we probably do observability on AI agents, I want to quickly delineate two differences, right? When you talk about evaluating agents, there are two broadly there are two types of evaluations, right? There is the offline batch evaluation, which happens in the development stage. So what happens in a development stage is you typically, you build an agent, you generate golden data. Golden data is essentially a good truth data of, for a given input, what should be an expected output, right? And then you use it to rigorously test. And how do you build this? We'll talk about how we can build golden data a little later. But let's say, magically you had a way to figure out, hey, for a given input, what should an apt output look like? So in your development stage, as you keep developing your agent, you use this golden data to test your agent, and that agent could that's the first stage, right? At the development stage, we are constantly trying to iterate. We are trying to run experiments using this golden data on the AI agent, and then figure out what is going wrong or what can be improved, right? Let's say we've still not gotten into, say, an evaluation metric, but let's say there's an accuracy metric, which just says that, hey, given an input, agent gives an output, and that is compared against the golden data's correct output that we've defined, and then how close it is, right? Let's say there's a measure of closeness between both the answers, and that similarity has to be at 95%. Let's say that's the metric. So you run experiments multiple times to see and keep making changes. You iterate, change tools, you change the prompts, you change the models, you change the hyperparameters, and change the architecture of the agent itself till you can get a good quality on that similarity metric. So that's on the development stage, right? Now, eventually, you also go to production, right? So once you say you have met your goal of saying that similarity metric has to be 95%, you go to production. Now, at production, you don't have golden data. That's the primary difference, right? It's no longer offline batchy evaluations that you're doing. You're doing online evaluations, right? You're doing online live evaluations. So you go to production and you're actually getting real-time inputs from the customers, and the agent is giving out real-time outputs, and you're evaluating these agents real-time outputs, right? Now, this is slightly different in the sense that you don't have the correct answer, but you still have to evaluate how well the output has come out, right? You still have to evaluate on, say, you cannot do a similarity metric like we did in the development stage, but you still have to have a measure of what is the correctness, right? What is the right answer that is coming out. So that's something that I wanted to put in a sense early on, so that we don't get confused between using golden data in the development stage, which is more batchy, which is more offline, versus real-time data in production stage, which is live and which is online. I hope that's clear.
Yes, sorry, one question here. There is also this concept of iterative development, right? Based on production, and a lot of these products keep getting built once we get like production data, etc. So do you also update the golden data set with live data? Any thoughts around it?
Yes. So while as we go to production, so some of the times what happens is, of course, we have great golden data. So production data also mimics the golden data. So it's great because we have an existing tool that we're trying to automate, and we've built great golden data. But a lot of times what happens is we're building something really completely new. At that time, you don't have great golden data. Maybe you've created some synthetic data, some basic golden data to start with, and then you go to production sooner so that you can learn from production, right? So as you get different types of questions and as you see failures, right? So what you start doing is you start monitoring failures. And when you see failures, and these failures can be measured in different ways, right? Say the user is unhappy, user gives a thumbs down. Now, when the user gives a thumbs down, user is unhappy, you can specifically look at that failure and then learn that, hey, this is a failure because this type of data was not there in my golden data. The agent never knew how to, or we never evaluated the agent on this type of data. Then you promote that example into your golden data so that you can go back into that dev mode of iterating and improving the agent. So this is a cycle as well. So you learn in production, take it back to development, promote the example that you got from production into your golden data, and then iterate and improve your agent again in the development stage. Yeah, I see another question. So, Atul, do you have a question?
Yeah. So on this, Gautam, like we know there is a thumbs up, and down, but is there any other way to kind of understand because customers or users won't always do thumbs up and down for a particular data. Is there an alternate approach to this? Or
there are alternate. Sure.
Or we can just I'm not sure whether all customers would allow that capturing that response. But I do believe most of the applications, I think in upfront ask for permissions of recording that conversation. But is there a program just kind of taking those responses and signaling that this is the right response, is the wrong response, and then feeding back to the.
So there are three other ways here, Atul. I'll answer that. That's something that I'm going to cover later in this slide. But there are three other ways, right? It's not one way. There are three other ways. Number one is, you'd see this in ChatGPT as well. There is something called implicit feedback. What we just spoke about, thumbs up, thumbs down, is explicit feedback, right? So explicitly, the customer is saying they're happy or unhappy about something. But sometimes you have implicit feedbacks. Now, what are these implicit feedbacks, right? Let's say you get an answer and then the customer copies the response. That's an implicit feedback that the customer likes the answer. Or the customer regenerates the answer. There's a regenerate option you see in ChatGPT, right? Or the customer asks a follow-up question. Or the customer closes the window and then there's an exit, right? So there are ways to figure out, hey, some of these are positive actions, some of these are negative actions, right? These are implicit responses the customer does, which can also be measured to see whether the generated response or the AI agent's response was correct or incorrect, right? That's one way. The other way is human in the loop. So sample up some of these responses and send it to experts. Ask them, hey, do you agree with these responses? And then the experts might say, no, they agree, they don't agree, they disagree, or they say they agree. And that's another way to learn. And finally, let's say you have a good amount of responses from experts. You can also train your own, or build your own LLM judge, which can help you scale this process, right? So you can have maybe a much more powerful LLM, which is aligned to these human experts and can understand that, hey, this is what human experts like and this is what human experts dislike. And based on that, mimic how the human experts' judgment would be on a larger set. Of course, using human experts on every single response might be hard, especially because it's costlier. So you could use an LLM judge, which is aligned with a human expert to generate this accuracy score. Those are also approaches. Hope that answers your question, Atul.
Yes, it does. Thanks, Gautam.
Perfect. So I'll move on, right? So before we go into evaluation itself, the first thing that I want to talk about is observability, right? So of course we'll evaluate. Of course, there are metrics that that we're going to use to evaluate. But even before that, let's think of let's start discussing about observability, right? So what is observability? Observability is essentially, making sure we track the agent correctly, track every step or everything that the agent has done or the overall software has done correctly, right? Now, there are three aspects of it. Of course, there's logs. People are familiar with Splunk. There are so many logging systems out there. So not just the agent, but prior to the agent, what the user has done, how the system has responded, and after the agent's response, also, what's happening. So you kind of timestamp, log all of these responses. That's the first thing, right? Think of that like a diary. Basically, you have timestamped events that you've recorded. That say something happened, user gave an input at X, what happened next, and then agent gave a response, output at Y. So that's you're just logging all of these things, right? Logs are great to do the error measurement. And now, and the next thing is the agent story, right? So the next thing is traces. Once you have the logs, now how does the overall trajectory look like, right? Like what happened first, what happened next, who called whom. So having a map of that whole logs as to how the whole trajectory worked through, that's another part. And finally, the evaluations and agents come, right? Because agent evaluation comes. And the reason is, if you don't have logs, if you don't have the agent's story or agent's trajectory, you cannot evaluate, right? You need the output, of course. You need all the decisions the agent took internally. You need the timeline of these events so that you can clearly measure the metrics that you want to evaluate your agent against. I see there's a question. Or
No, it's not a question.
okay. Okay, how well? Yeah, that's a different topic. So judges, of course, if you're not aligned, they'll fail anyway. And then if judges, even when judges are aligned, they may fail. So there's a caveat to using judges. Thanks for sharing that, Bala.
Yep.
Let me quickly share my screen. So can you see my screen? Only now I'm showing perfect. So I'm going to show the traces in Langfuse. That's a tool that I've been using, so I'm more familiar with it. Also open source, free to do. So that's something that I've used. So what I've done is you could all just go and create an account in langfuse.com. Go and sign up. You'll get keys. And what I have really done in this particular notebook is I've just picked from their docs, I've picked a notebook that they have given for getting started. So just add your Langfuse keys and you can get started, right? So I'm just going to quickly show you how the traces look like. So I'm using Google ADK. Feel free to use OpenAI. Feel free to use any agent, and they have example notebooks for all kinds of agents. So feel free to use whatever works for you. I'm just using something that I'm more familiar with. So the Langfuse client is authenticated, installed. This is going to use. Okay. So I think their default example that they'd given was, just says a hello. So I've just shifted it to a Q&A agent, made some minor changes to the code just to show some examples. So running it now. Oops. I think I opened the wrong notebook. One sec. This is the right one. Sorry about that. So Santosh, what do you mean by auto instrument?
Just to confirm, once you write those, once you import Langfuse and few lines of code, you don't have to keep instrumenting the code, right? I mean, it just
No, you don't have to. It uses open telemetry and it'll instrument. So this is the authentication, and then you're done.
Oh, nice. Okay, so it has its own rules to figure out where to go and instrument traces, etc. Right? So
yes.
Okay, sure.
So yeah, that's one thing that's. But I think most of the providers do that now. Everything is based out of open telemetry, and then they've written their own rules. So I've run this. Let me open my Langfuse in this one. So we go to Langfuse. Typically, you'll get you'll have to create some organization. There, for some reason, they operate this way. So once you create an organization, you'll get projects to log into. I think there's a project where I'm pushing my scores into. So once you go into go into Langfuse, what you will see is you'll start with a home page which shows, what were the traces, whatever model calls that you've made, what is the cost of all of those calls put together. If you have set up some scores, especially around evaluations, how do those scores look like? So you get a lot of useful information. You can also go and there are some specific dashboards that they've created off the box that I found useful. I've also created my own. So go feel free to create your own new dashboards just to see how the performance is. And there are great video tutorials for this here. So you can try it out. So I'll go to the trace. The trace that I just ran, you'll see is here. Let me switch off my judge. The trace I just ran is over here. So what you see is you can see the timestamp. You can see what app was invoked, what was the input, what was the output. You can see the latency, the overall latency of the input output. You can see how many tokens were used, what is the cost, and some metadata. The good thing is you can publish whatever metadata you want. That's something that I like about this. Even during the thinking, if there's some metadata that I want to publish, I can keep publishing that metadata here and later use that for my evals, right? So that's great, right? Like, let's say, did the input have an image or did the output have an image? Things like that. These are things also that I can publish as metadata and then I can use them later, right? So this is how a typical trace looks like. Now, if you click on this trace, you will see the actual trajectory, right? So my agent was invoked. When the agent was invoked, it called this tool. The ask agent is the tool. My app ask agent is the tool which calls the LLM, which makes an LLM call, gets the response, and then gives you the final answer. Right. In this case, I think the question that I had asked was, what is US GAAP accounting principles, and it gave a response. So yeah. So this is what we call as spans. Spans are basically every call or every invocation or every step that happened in the overall trajectory. That's called a span. And you can actually look at the details of the span, right? As to what was the input, what was the output, what was the metadata used, what were some of the IDs that went through. So all of that information is here. I am not going into details in the interest of time, but feel free to, explore. Just go to Langfuse, open their docs. They have sample notebooks. Just try it out and you'll get an understanding of what's happening. The timeline view is also good. It kind of shows. Just expand this a bit. It kind of shows when how much time each of the step took, and internally the steps that were happening, how much times, what time each of that took. And of course, you can see the trajectory internally. As you start, you invoke the agent, then it asked the app as the underlying tool, etc. Right? This is great. This is something that it's easy for me to debug when something goes wrong. Easy for me to quickly check, hey, what's happening? Why things are going wrong? And the other good thing is, what Bala just spoke about, right? Let's say I want to, as I'm going through some of these traces, and I want to add a comment. I can add comments, or I can annotate them and say that, hey, this went wrong because of XYZ reason. I can say, hey, went wrong because of whatever, right? There's some setup that you have to do. You have to go to settings and set up what kind of annotations that people can do, free text annotations versus scores, etc. And then the last thing is adding to datasets, which again I was talking about, right? Like, how do I add it to my golden data? Let's say, I've already created a golden data in my datasets section. So I have some datasets here. So I can, if I feel a particular trace is worthy enough for me to promote it to my golden data, I can go ahead and add it to my golden data set. So this shows me what should the input and what is the expected expected output. Like I said, a golden data set typically has what's the input and what is the correct output that is typically to be expected. So I'm assuming that this is the right one. I can edit here. If I feel some of this is wrong, I can make edits and I can then select whichever data set I want to add and then add it to the data set. So this way I can, if I find a problematic trace, I can annotate and I can also make edits to it and add it to my golden data set, so that in future, whenever I run in my dev environments, I can test it against that golden data to see how well the actual agent performed. Any questions so far? Am I going too fast? I hope I'm not going too fast.
Hey, Digvijay has asked a question.
Oh, okay.
Hey, first of all, this is very helpful. Very hands-on also. So this is, yeah, making a lot of intuitive sense as well. One quick question that I had was, you mentioned about, let's say, we gave a really good example about sometimes it's something that happens on with the ChatGPT and Grok as well. And the image is, let's say, not coming, even though when you ask for image generation and you mentioned that you can add that in the metadata, whether, let's say, the image came or not, right? So how do you customize or publish that metadata? Where do you kind of do that? Or if there's if it's easily available in resources docs?
Available here. So just go to their docs. So Langfuse supports multimodal. So it's not just just text. So you can do images as well. And the good thing is most of it is available as either interactive demos or you will find them as notebooks, right? So just go to their docs and then start asking questions. Okay. You'll typically get whatever answers you want, right? Like right from so honestly, what I've used the metadata. I've just copy pasted their code snippet and used it, right? I'm not trying to understand what exactly they're doing. I just copy paste the metadata, copy paste that snippet, and then just tweaked it to input the metadata that I want. That's all.
Understood. So there's a boilerplate that is there, which is good enough that you can use. If required, we can just change it as well. Great.
Yes. The boilerplate is pretty good.
And I'm assuming that on the basis of, let's say, that metadata also, you can slice it and then add those things to create a new data set as well, like wherever, let's say, it failed.
Yes, you can filter by metadata. Okay, let me show you. I don't know if I've added some metadata here.
That's okay.
Filter by metadata. So you can do some. Okay, let me just. So you can filter by metadata. Okay. Let's say I want to search by some metadata, right? Some input, some search. You can filter by metadata. Here I have not added any metadata for this particular example. That's why it's not coming up. You can filter by metadata. You can push those metadata specific. Based on that metadata, you can pull that into your golden data set.
Yeah. Thanks. Very helpful.
And then there's also sessions. I don't use it much, but I can tell you what it does. It gives you all the conversations that happened within a session. So let's say I open, there's a multi-turn conversation that's happening for a particular, the entire multi-turn conversation is called a session. And then for a particular session, whatever multi-turn conversation happened, all of that you can find it here. So think of trace as single conversations, just every single turn that happened will come here, and session as the group of all of those turns within a session that happened with the user. Okay. I'll move on if there are no questions. Yeah.
Hey, one quick question, Gautam. Connect this Langfuse to your apps, right? I'm just wondering whether enterprise would allow that, or is it like?
Very good question. Very good question. Today it doesn't. So there are certain advantages of using Langfuse. So Langfuse not just allows you like a SaaS. They don't provide just a SaaS. They also give you a hosted version. So if you want to host it on your own premise, you can host it. So that way, that's one way to overcome this privacy issues. Say, it's your own hosted version. They don't have access to your data, so you can send, you can send all data here. That's one. The other thing that you'll have to do is you will have to do some kind of masking of data here. that's the other way to, if you have some personally identifiable information, you don't want that to be saved, then and you don't want to use the self-hosted instance because it's costly. You don't want to host it. You want to use the SaaS option. Then you will have to do the masking. And there are good masking libraries that you could use to do masking. That's something that we've explored. But yes, there is still a risk. None of those masking libraries are also 100% accurate. There's still a risk of say 1 or 2% personally identifiable information coming through and then getting stored. That's a risk. But that risk stays with everything, every tool that you use.
Got it. So is there any alternative to Langfuse, like which are more enterprise approved kind of platforms, right?
Actually, this is an interesting conversation. So this is a space where even the biggies have not really broken and created something. Like when I mean the biggies, I mean like the Googles or the Microsoft or Amazon. They don't have a very clear tool yet. Google has somewhat of a tool. Still, I've used it. I've not really had great experience with it. But the ones that are really at the forefront right now is Arise, Phoenix. That's their tool. Then you've got Langsmith, which is the Lang chain set of tools. These three and Langfuse, right? So these three are the forerunners right now in the market. There's also weights and biases. Sorry, I missed that. These four are the forerunners in the market right now. Weights and biases, Arise, Langsmith, and Langfuse. Of these, Langfuse is open source. Phoenix is sort of open source, not completely open source. And therefore, Langfuse is cheaper, like probably 1/10 of the cost. So yeah, I mean, if you're okay to, if you want an enterprise, like a bulletproof enterprise solution, then I guess typically I've seen people using Langsmith and Phoenix. If you're more of a startup and you want to be more cost conscious, then I've seen more Langfuse being used. Langfuse, the good thing is it being open source, you have a lot more flexibility.
Got it. Thanks.
Perfect. I'll move on. So now that we kind of understand, hey, what's the prereq for eval, right? Even before we do eval, there's observability, there's tracing, there is logs, etc. Now let's talk about evals. So when we let's talk about what and the how, right? Those are the two aspects I want to definitely cover today. So what are the pillars of eval metrics, and what are the typical eval metrics that you need to think about when you think of creating eval metrics for your agents, right? There's efficiency metrics, there's effectiveness metrics, and there's trustworthiness metrics. Now, what's efficiency metrics? Efficiency metrics are typically the more operational metrics. Your metrics around, hey, what's the volume of tokens being used? What's the latency? What's the number of steps being taken? What's the trajectory complexity, etc. Right? More of operational steps. Then there is effectiveness metric. This effectiveness metric is what people typically think when they think of evals. This is around, what's the accuracy? What's the helpfulness? What is the intent understanding, how good it is, things like that. And then finally, trustworthy metrics. These are around safety and alignment. Hey, are we following the ethical guidelines? Let's say PI information not being shared, right? That was a good point that I think Vijay brought up. So what if your agent is sharing PI information when it should not be sharing, right? Is it following the guardrails correctly? So there's a little bit of overlap between eval and guardrails, specifically in this trustworthiness or the safety and alignment aspect. Moving on, now how to perform evals. We spoke about this a bit earlier as well. There is automated evals, there's human in the loop, and there's end user feedback. Typically, don't rely on any one of these because all of these have their own advantages and disadvantages. We'll talk about them. Now, automated evals. Automated evals, there are broadly two types of automated evals. There's either code-based evals, so which is things like similarity. Now, just to give an example, right? Let's say you have a ground truth, which gives you, what's the input and what a typical output should look like, right? Now, your agent are if your agent is giving a response, you test your ground truth against your agent, and your agent gives a response. Your agent gives some response, right? Now you can measure similarity between that response and with your ground truth, and that is called a similarity metric. This is a statistical metric. You don't need to use a LLM for measuring this. So this metric is fairly. This is what we call as, you write a simple algorithm to measure this metric, right? Now, the other type of automation is using LLM as a judge. Now, LLM as a judge is basically you use a slightly bigger or a more advanced LLM to make a judgment call about the output that your agent has generated. Now, how good it is, we'll talk about how we can make LLM as judge better, how to align LLM as judges to give better responses. But the good part about it is LLM as judge can scale. You can run it through all of your outputs as long as you don't have a cost constraint. Of course, larger LLMs, if they're going to evaluate your output on behalf of a human, it's going to be costlier. So keep a note of that, right? So automated evals. So the key takeaway is it's scalable. You can do it for all your outputs, all your trajectories, but it can be costly. Now, the next is human in the loop. Human in the loop is when you try to get an expert to actually evaluate your outcomes. So let's say, to give an example, right? Let's say we spoke about the trip planning agent, right? So there's an agent that does a trip planning for you. So let's say there's input and then there's output. If you actually show it to a trip planner, let's say you go to a travel agent, real travel agent, and show that, hey, this is the response that my agent created. What do you think about it, right? And the agent and the human travel agent, he or she gives a response saying that, hey, this is good, this is bad. These are things that the agent did well. These are things the agent did wrong. Those are the cases of human in the loop scenarios, right? Where a human is actually judging the output. By default, not scalable, because you cannot have humans looking at, if you're going to get humans looking at all your outputs, then you might as well get humans to do the work and not the agent. So that's the downside of it. Not scalable. And the other downside that's coming up off late is, since the agents are getting better and better, you now need really good experts to evaluate, right? And these good experts don't come cheap. Earlier, what used to happen is, let's say I'm not a travel agent. I could evaluate an agent's output and say that, hey, this agent did a great job of this, did not do a great job of this, right? Of something else. But now the agent's output are pretty good that as even though I'm not a travel agent, by not being a travel agent, I'm not able to give a good judgment of the response to the AI agent's response, right? So you actually have to go behind experts to evaluate, and these experts don't come cheap, right? And this is something that in shortage of experts is a real problem that a lot of companies in Silicon Valley is trying to handle right now. How do you get experts for the right task, right? Especially in finance, especially if you want to get something around accounting, you need to get good CAs looking at it, or good CFAs, or good CPAs looking at things, right? So that's another problem statement that things like Scale AI, etc., are trying to dabble around with. And then finally, end user feedback. End user feedback, again, like I said, there are two types of end user feedback. There is explicit end user feedback, thumbs up, thumbs down. There's VOCs, there's NPS scores, etc. And then there is implicit feedbacks, where follow-up questions are being asked, copy, retry, share the answer with someone. These are all implicit feedback. Some of these are good, some of these are bad. So if you can track these as part of the agent's response, that will also give you a good understanding of whether the response that the agent gave is apt or incorrect, right? Some of these, some people also allow to edit the response that the agent has given. That is also a good way to take user feedback, right? So one thing, as specifically for PMs, try to be more innovative in getting end user feedback. This is as close to good and good feedback that you can get, the best feedback that you can get, right? Of course, the real problem with this end user feedback is you typically don't get end user feedback. No one typically goes and presses thumbs up, thumbs down. So try to be innovative, allow people to edit answers, allow people to do certain steps, gamify it so that people actually end users actually give you feedbacks, because that's really good feedback for you to go back and improve your agent. These are real-time feedback and coming from the horse's mouth, so that's why it's super useful. I want to cover some more content, but I think we're on the last 4 minutes. Are there any more questions? Should we take questions, Bala, or can I go for another 2-4 minutes? Like, what's the typical?
Yeah, go ahead.
Okay, there is one question. There are some questions. Okay.
Sorry, just Gautam, thanks so much for this. Just in my mind, to get this right, to wrap this around. So you mentioned observability and then eval, right? So is Langfuse, if I look at the tooling, so observability becomes the precursor to eval. So I have to, it's like the tooling part of evaluation. I'm right. Observability is what you're saying.
Yeah, observability is the precursor to eval. So if you want to say, let's say, we discussed about trajectory, right? Trajectory is basically what steps the agent has taken, right? Unless you're already storing the steps that the agent has taken, or the inputs and the outputs that the agent has taken or provided, you cannot evaluate it, right? At the end of the day, what are you evaluating? You're evaluating the input to the agent, the output to the output of the agent, or the steps that the agent has taken, each of this, the intermediate input outputs that the agent has done, right? Unless you start storing this and in a way that makes sense to you, in a way that it's ordered, it's connected, in a way that makes sense to you, that's when you can start evaluating it on any metrics, right? So observability in my mind is a precursor to evals.
Okay. Thank you.
Yeah, Sharat, you got a question?
Hey, Gautam, in multi-turn conversations, right? Not every turn is like worth evaluating. There are only like certain value add turns where something gets like inferred and responded back, that kind of a thing, right? So then, how do you determine when to actually do eval and when to just pass evals and not really evaluate that conversation turn?
So, couple of things, right? What I have been doing is, one is, ideally as a product manager, I want everything to be evaluated, right? But unfortunately, the scale and the cost does not allow me to evaluate everything, right? So in such scenarios, two options. One, sample conversations, just do random sampling and evaluate. But again, random sampling, when we do statistically, random sample should cover all scenarios. But of course, we are always worried that, hey, what if the failure scenario is missed, right? What if a particular scenario that I want to evaluate is being missed, right? So in that cases is where the second approach of adding metadata helps, right? So as I work with agents, like there is some intuition, Sharat, you might have that, hey, this turn is an important conversation, whereas some other turn is not an important one, right? There's some metadata that you can start populating. Say, if an image comes or a smiley comes, it's an important conversation. Or if it is more than 10 tokens, then it's an important question. If it is less than 5 tokens, it's an important question, right? Populate this as a metadata, and only when this metadata gets populated, trigger the eval. Right, so you'll probably still do logging and tracing. You'll do observability, but on the observability, you create a logic which says that, hey, if it's greater than 20 tokens or the response is greater than 50 tokens, that's when process it through my eval. Otherwise, don't eval. That could be one way of trying to figure out which ones you want to evaluate and which ones you don't want to evaluate. Yeah, Nishant, please go ahead. Nishant, can you hear me?
Nishant, you're not audible.
Oh, he dropped.
Okay.
Okay. Any other questions? We just have a minute. I'll just give you maybe a precursor of what I want to do in the next session, right? So I want to talk about the golden data, because getting data is a hard problem. So how do we get data? And then when you're actually doing eval, what is the steps, right? What's open coding? What's actual coding? When you're actually doing evals, how do you identify errors? And how do you use those errors to create the right metrics? And what is drift detection within evals? We spoke about a little bit earlier, and what is drift detection? And finally, I want to talk about some patterns, say what's multi-judge LLMs, what is judge calibration, what is eval trajectory evaluations. RAG I will not cover because it's already covered. So, and eval issues, how do we connect, right? So these are the areas. I'll share the deck with Bala. If folks are not able to join the next session, they can definitely go through this. But that's what I intend to cover in the next session.
This is awesome. I was about to ask for the deck. I think we still have a lot more content even for next session. We'll see.
Okay, I'm happy that we covered observability at least fully, because that's an important area. A lot of people don't miss out. So happy that we could cover that.
You can always make it a three-part series. We can't cover.
Okay, sure.
Yeah. Guys, a reminder, right? So we're not doing the second part of the session next week. So next week we're doing a session on Cloud Code. The week after is when we'll have part 2 of this session. Okay. So all these invites are already there on our website. Just have a look if you need. Gautam, anything else?
No, I'm good. Thanks everyone. I think great questions there. Some of these questions are things that I keep wondering about as well. So great interaction. Thanks, guys.
Yeah, I think Deepak has one question. Just before that, responding to Atul's question, right? So Atul will be uploading this recording on YouTube. So on our channel, it's also called AppliedAI Club. You can find it on our website. That will happen by tomorrow, and I'll post a message on the group, so you can access it that way.
Thank you. Thanks, Bala. Thanks for the session.
Deepak, go ahead.
Yeah, hi, Gautam.
Here
Thanks
you
for the session. It's really helpful. I don't know if you would cover this in the later session. You just talked about what are the different techniques of evals, right? So, and you also said probably we may have to use all or at some point of time. So, any best practices? What could be the best combination, or during a scenario?
Deepak, I lost you.
Yeah.
Can the others hear Deepak?
No, I can't either.
Okay, Deepak, I'll answer based on what I understood, right? We will cover some of these later. My experience, so see, eval itself is a fairly new topic, right? So it's not like there is best practices that have come up in every single scenario, right? So it largely depends on your use case as well. My suggestion is, in general, try to do all three and measure the drift between these three as well. See, let's say you have a common evaluation metric called accuracy, let's say. Then human in the loop can also give you a measure of accuracy. Your automated eval can also give you a measure of accuracy. Measure both and then compare the difference, right? Sometimes those also give you interesting feedbacks, right? So human in the loop might say, hey, accuracy is only 50%, whereas your automated LLM might say accuracy is 90%, right? So all three are useful, and doing pairwise comparison is also useful. So the general suggestion is do all three if possible, assuming cost allows you, bandwidth allows you, of course, all of these caveats. But if possible, try to do all three.
Got it. Thank you, Gautam.
Awesome. Any other questions, folks? Otherwise, we can close.
Yeah, I have a question. Yeah, hey Gautam. So what we saw right now was like a turn-by-turn eval, right? What about multi-turn eval? Like, is there somewhere where we can see whether the end objective of the conversation was kind of met? Do we do like a like, okay, there were some parameters that had to be filled, out of which how many were correctly identified, something like that?
Yeah, so that's so you can do session level evaluation, and let's say at the end. So there are two ways, right? Again here, So let's say in the agent itself, we've codified that a typical output should have XYZ parameters, and it should be, say, in a JSON, in a structured format. These are the three things it should have. If you can use it like a guardrail, you codify it in the agent and then you use it. Or B, you can have an agent, the code-based eval I spoke about, right? In automated eval, you don't need to have a LLM to do this. You can have a code-based eval which just looks at the response and then finds, hey, are these three things available in the response or not? If they are not, it just says that this is a wrong result. Fails the eval. As simple as that. Yeah. In automated evals, prefer using code-based evals over LLM evals, primarily because against LLMs, they're non-deterministic. They might end up giving answers. You have to be really careful how you align these LLMs to give the right answer. So whenever possible, if you can use similarity metrics, algorithms, or code-based evals, use them.
Right. And how do you test that? So for a single turn, it's very easy, right? You kind of give it a fixed data set and you have a response for that. But here, do you create an LLM, like a agent itself that communicates with your agent, and then if you want to run.
You can create simulators. You can create simulators. So one thing that we do is, so based on past conversations, right? We use that past conversations as RAG and create another agent, which is like a simulator.
Okay.
So it will mimic user conversations. It has the memory from RAG, mimics user conversations, and then asks questions.
Right.
So good for customer support bots.
And is this available in Langfuse out of the box, or is there some other platform?
Not right now. You can find this a lot of GitHub. You'll find open source repos for this. This is a common problem right now in the industry, and you'll find a lot of repos that address this problem here. Just search for simulators, agent simulators for evals. You should get.
Okay, thanks.
Okay. Awesome. Nishant has a question. Wanted to understand about golden dataset. I understand they're representative set of input, but during dev, how is the output being generated, measured against what it should really be? So golden dataset, typically the way golden dataset is created, Nishant, is you actually take it from an expert, right? Let's say in this travel agent example, you will generate some sample inputs, and then you'll give it to an expert and say, hey, what should an ideal output look like? So an expert will generate these outputs and give you and say, hey, this is how an ideal output should look like. Sometimes we wear the hat of expert, but typically it should be an expert who's a domain expert in that area who can define what is a good answer. Sometimes you might actually have to use multiple domain experts and then figure out what is the best answer, kind of rationalize across all of those domain experts to find out what is the best answer. Right? That's one way of creating these golden data sets. And once you have this input and the expected output, you send the input to the agent, you get the response from the agent, compare the agent response against the expected output in whatever, and use whatever metric to measure the performance. So this is how golden data sets work in training. So every time you make a change, you send the inputs to the agent, get the response, compare it against the expected response. And for you to measure, you can measure if there is an improvement, right? Let's say you measure something like a similarity or an accuracy. If the accuracy improved, the underlying change you made is a good change. If the accuracy did not improve or remain the same, then the underlying change you made is not a good change. That's how people use it in development. They run multiple experiments, change models, change hyperparameters, change a bunch of underlying things to see if the response accuracy improves against the golden data set. Hope that answers. Cool. So,
awesome.
Yeah.
Super. Thanks a lot, Gautam. This was fantastic, actually. I'm looking forward to the next session. So, folks, we will you can upload this recording on YouTube, and I'll post a message on the group. Thanks a lot for joining, and have a great weekend. Take care.
Thank you.